Good evening, all. This is uh, this is week number three. It means we have already finished half of our journey on this learning path. Last week was very happening, at least as I see, because we have covered a lot of topics. We have started from understanding the NX object, the hierarchy of these objects, then their inheritance nature, how they inherit each other. And this has helped us a lot to understand the API structure. And not just structure, but it has also helped us uh, know how we can effectively navigate in the namespaces, in the classes, and in the APIs. Prior to that week, you already know the constructor. You already know which what is API, uh, how we use, not how we use, but how it looks like, how API looks like. There are some parameters that we define into bracket. But last week you're able to understand this structure, and believe me, this knowledge is going to help you in long run. Anything you go and develop here onwards, this structure, these objects understanding, this hierarchy understanding is going to help you a lot. Then also we tried to uh, see some examples. We have seen examples related to curves, creation of arc line, um, and then we have also seen ellipse, point, expressions. We have created few expressions. Then we started with uh, creating objects via builder. So before that, when we create point or like, that was non-associative, and with builder we have started creating associative type of features. We have started with arc, but then we recorded a journal uh, to create a line, and that too associative line, and we have tried to reverse engineer how that line builder is used, and then we started looking into Visual Studio as well. So we have done coding a lot on a journal editor. Then we moved to Visual Studio. We have also seen the powerful capabilities of Visual Studio, and we have written few codes there as well. And to end the week, we have touched upon creating extrude builder. There are a lot of parameters we require in such kind of features. For example, revolve, for example, extrude. And there is one more, not one more, but couple of additional things that we need to take care. For example, section. And then inside section, we need to provide the input sketch entities so that the extrude or revolve will happen. And that is the another important parameter, selection of these sketch entities. So we have seen curve dumb rule, that was very simplest one to look at, and this is how we have seen extrude builder, and we have done reverse engineering for revolve builder. We Because that is also one of the way, recording a journal is one of the way that can help you create builders successfully, because that gives us a lot of knowledge about what parameters exactly are required. Though we, though our knowledge of using those features manually in CAD also helps a lot, but that is one more uh, uh, obvious thing that you can use while you go and create a builder yourself, that you haven't created before, that you haven't seen before. So this was the week that we ended up, and this week is again the another ride, but in the different terrain, I would say, because last 2 weeks we were not moved out of part environment, but now we are going to move out of part environment, and we are going to start with assemblies. So this is going to be a week where we will be discussing about assemblies, and we will also might touch upon drawings. So let's start. I will share my screen. The difference between part environment and assembly environment. Actually, uh, we don't need to take care about this difference at all, because uh, as you model in a part similar way with some different features, you model in assembly. There is no much of a difference. Yeah, there is difference, but as you get used to it, whether it is assembly drawing, that doesn't matter a lot when you create models. The similar is for programming point of view or NXOpen point of view. The only going to be changing is that the namespaces that you are going to use, nothing else. And but though the namespaces, the classes are going to be changing, but that structure, that framework is going to be same. And again, how you are going to use them, how you are going to use those APIs, create the automation is also going to be same. But what is going to be different is you are creating the automation. You are using these programs to automate few things, certain things into assemblies. So when we talk about part, we talk about sketches, we talk about features, we talk about expressions, and what else. So these are common things we talk about in part model or part document. When we are into assemblies, we deal with components, we deal with constraints, we deal with arrangements. So this is what is the difference uh, overall. Okay, so let's start. Let's start. Obviously, we are going to start with API guide. So okay, so let's try to see some namespaces which are related to part. Uh, NXOpen dot annotations, though it is lot of things related to dimensions and annotations, but there could be certain things uh, that are available in part. It is not always drawing. Some annotations we even use in part. So this is relevant to part, I would say. Then mm, next one for part is display. NXOpen.display is relevant for parts. Then facet features, then some other features related namespaces even. Then layer, of course, options, definitely it is to deal with the options and interfaces. Okay, these are few related to part. Now, for assemblies, we do have these namespaces. NXOpen.assemblies. I haven't come across this namespace that much. NXOpen.assemblies.product interface. But as name suggests, it is also related to assemblies. Now, what else? Those two only look relevant. Even the things like feature, layer are also there are some of the classes could be those are relevant to assembly. Again, this one as well, and it's open.display. So there are few specific dedicated namespaces, but there are some common namespaces as well. So let's jump into NXOpen.assemblies because this is the important namespace for assemblies. So obviously under namespaces, we do have several classes, and these classes are related to arrangement. Of course, we'll have a lot of builders as well here, because any object you would like to create, there could be a chance that there is a builder for you to use to create that object. So I'm talking about object. It means it can be anything, anything. While we whatever we can create in NX, that can be object, or that whatever we can deal with in NX, that can be object. Okay, so we do have assembly class, we do have assembly manager. As there are few features or functionality like clearance set, analysis, clearance analysis, then arrangements you have seen. So other things in assembly. So those are capabilities, those functionalities. We do have classes for that. Of course, we will have a classes for constraint as well. Here I see constraint display builder. We do have the classes for component related things, component assembly, component group, component order, component pattern. Because lot of times we deal with components in assembly. So this list is huge list of classes. Okay. Uh, so this is the NXOpen assemblies namespace. And before we start, I can show you couple of classes so that you get some idea. Let's start with assembly. Now in assembly, uh, what you need to look at in this class is you're not going to use some API from this class right now. What you wanted to do is you want to understand what this class means, where this class can be used. So as I already shared with you, how you understand about this class is definitely going through this page, but you don't need to go through in detail, but you have to look at this table, and you look at this table and read a few of the APIs. Get attribute tiles by name, by type, get boolean user attribute, get lifetime service. I think there are a lot of them which are not relevant to assembly. Those are inherited from next object, I see, because those look very generic in nature. Let's remove this inherited option. So there is no very specific to assembly class. This is strange to know. Okay, but what at least we can know from here is that at least in hierarchy point of view, and inside a tagged object, we do have NX object, which is a broad level object, and assembly is one of that. Maybe there is no relevant thing in this that we can use as far as assembly is concerned. There are a lot of things here. For example, name is occurrence, owning part, owning component. But though this is under assembly class, you can see, but this is very generic kind of APIs because these APIs are inherited from NX object. NX object means any object in NX, we can use these APIs. So let's move on and find out something assembly specific. Assembly manager. This could be a specific one. And what I notice here, there are several builders related to assembly. Create constraint display builder, create hide component builder. So if I want to hide the component, I can use this builder. Create new component builder. So creating new component, I can use this builder. Create replace component. If I am replacing a component, this can be useful. That's it. No much of things here, but this class certainly can be used to create component related builders. Fine. Now I can go to these two, which are again very important ones, and this can definitely confuse you a bit because they look very similar, component and component assembly. So let's get into component first, and let me untick this. And if I see direct owner, design element revision, display components extract, display name. This looks, this I can understand at least. Display name, it returns displayable name of a prototype part. Then fix constraint, returns the fixed constraint of this component. We know that when we place a component into assembly, there are some constraints that we can apply to it. If it is a first component, then we apply the fixed constraint to it. So this probably is related to fixed constraint, this particular API. Then get children, this can return the child components of the component. Then get constraint, it can return all the constraints assigned to that component. Get degrees of freedom, it can return the degrees of freedom. So we, when we add constraints, then we get it fully constraint into the assembly space if it is not movable from any side. But if it is movable, then it means that there are certain degrees of freedom which are still open. So this API can get us that information. And there are more such APIs which are either fetching some information of a component and giving us that information, or maybe some creation related things might also be there. Set is there, suppress, so we are so suppressing a component, unsuppress is unsuppressing a component. Used arrangement, it can find out the used arrangement for the component. So these are component related things. So mainly access point for a component. This component class contains APIs for access point of component. Now component assembly. When there is a component assembly class, then what, let's see what is the difference then. uh, if I untick this, add component. Okay, so we do have several types of add component APIs. This is related to arrangements, clearance sets, component patterns, explosions, get suppress state, get suppression expression, remove component, root component, subsets. So what I see from reading these few APIs is component assembly class is related to the assembly environment rather than limited to the component. So earlier class, component class, which was related to component mainly, which was accessing that component object and are giving us lot of information about that component object. But component assembly class means it is nothing but the API is related to assembly environment, because when we add a component, we add it into assembly environment. When we deal with arrangements, it is unsaid assembly. It is not something very specific to component. Maybe component is playing a role there, but it is assembly related thing. Arrangements, clearance set, explosion, all of that. So this component assembly is nothing but assembly related APIs. Okay. So very few namespaces for assemblies, and most of the APIs which are common to the object, for example, NX object, which are inherited from other classes, other namespaces. And that's why if we only want to see the purview of assemblies, there are limited namespaces we do have. Okay, so with this, that's all for the introductory part of assemblies. Now let's move on. What is there on the slides to pick up next? Yeah. So get position example. It's time to start with the example. Let's try to write a code that can get the position of a component in an assembly. So we are trying to fetch something out of the assembly. We will try to fetch out the position in XYZ coordinates of a component into the assembly environment. So let's start. Let me have some assembly. It doesn't matter what assembly it is. We are not really bothering about it. We don't need to really bother about it. Uh, this assembly has three components. Same component repeated three times means one component, three instances of it. They are placed in different position and different orientation as well. Now we have to go and we have to start writing our code into Visual Studio. Now we will write mostly in Visual Studio and we will avoid using editor for the same. Okay, so let me share my Visual Studio screen. Okay, so I will start from scratch uh, using system, using NXOpen. I do have added NXOpen references, so this is why I see them uh, here. Am I doing something wrong? Okay, let's continue. We'll take care about that later. NXOpen dot assemblies. I have to call assemblies object or library as well because we are going to deal with assemblies. So we'll start with public class NX journal. I will keep it same name. We can even name it like this component position, get component position, because we can name it like that because this is what we are going to write inside bracket, then public static void main inside bracket string args bracket. Then we start with session. The session is equals to session dot get session. Get session bracket. Then NXOpen dot part space work part is equals to the session dot parts dot work. I need to take care of if IntelliSense is not giving me that option, then I need to take care of the uppercase. Okay, then now I do have written this uh, initial template code of lines. Now I will go and define the variables related to assembly. So you know that when we work with part, we need these two lines, session and work part. But the same is valid for assembly as well. The only difference is going to be is that we have to also access the assembly itself, means top level component of assembly. Top level component of assembly is assembly itself. So we have to deal with that. And for that reason, we have to declare the variables for that as well. So NXOpen dot assemblies dot component assembly. It represents the assemblies dot components. So, and then I will name it as comp assembly, and then is equals to work part dot component assembly. So I have to declare it like this. Then I have to so this way I have accessed the component assembly. Now why I use this variable is because I have to start from top, and in order to get the top level component, I need this API to use. So now let's declare another one, NXOpen dot assemblies dot component. So component assembly is declared. Now I will declare component. So it represents the component in component assembly. Okay, so object hierarchy wise, first comes component assembly, then a component. Then I will name it as top assembly component is equals to comp assembly, which is this variable comp assembly dot root component. Root component is, I think I don't need this bracket. Root component means it returns the top level component. That is component at the root of component tree. It means the assembly itself. But this is the way to get that assembly. So when you are dealing in the assembly, these two lines will be the mandatory ones when you deal with them. I think I can close this two brackets so that I will some errors will go away. Okay, so I done this. Now so we know that when it comes to the component name, it is going to be the string, and I have uh, to give that name as a input to find out the position of that component. So what I will do is I will define a string. I will define a string, and then I will name it as comp name, okay, is equals to. Now I have to check what is the name of that component in my assembly. So let me see. Name is this plate with holes. Into double quotes, I will mention the name. So I need this. So I have used this string. Now next is I have to also need the point, and I also need the matrix. But how I know that I need this? So I need to find out the API first. So let me get into the API guide. Now I am into component assembly. Drill down to the bottom. I don't find it in here in the hierarchy. So what I can do is I can get into component class, because we are dealing with component. We want to get the position of component. So I think it should be in component, because component class has the in the APIs related to fetching the component information. So get constraints, get children, all of this is here. Get position is also here. So this is what I am going to do. get position. I am going to get the position of a component. And in order to get the position of component, I need these two parameters, point 3D, which is orientation of the component, and then matrix, sorry, which is point 3D is origin of a component, and matrix 3 by 3 is the orientation. It can give me the orientation of a component. So this is the API that we are going to use, and you can see this under assemblies, under component, this is the API, get position API. So this is what I am going to use. It is very simple, only two parameters here. So I can get into writing my code further. What I will do is I will have a point 3D and matrix as well. So NXOpen dot point 3D. I will just name it as PT. NXOpen dot matrix 3 by 3. You can see there are two different types of objects for matrix. One is matrix 3 by 3, other is NX matrix. But we don't need to get confused into this. Our API says it requires matrix 3 by 3 as object type. So we'll just go and declare that. So I will name it as MX. Now I need to get the name. I have defined the name that this is what the name I am going to use. Rather, I need this component to be used, and I want to get the position of this component. So that information I have placed here. But this is just a name, but I need the object, the component object, because the get position API is within component class. It means that we need the object. We don't need just name. Just name is not sufficient. So we need to access that object itself before we get the position of that component. So what we are going to do here, we are going to introduce one more function. So this public static void, being name of this function is main. This one is the primary uh, function that is going to execute. But we need one more function, and that function is specifically to get the component object. So what I will do is, after this bracket, after this bracket indicates that this is the end of main function, right? So after first function ends, I can go and start defining other functions similar to how this main function is defined. So what I will do is, instead of writing public, I will write, I will not, I will start with static, writing it as static, and then I will name the component. Then I will name this function get component by name. So I do have name of the component, but I need to select that component from the assembly uh, as an object so that I can use that API, get position API. So I have to select that, or I have to get that object somehow. So for that reason, I am going to have this dedicated function, we can say. And as this is a function, I can even go and have some parameters inside this function. So in order to find that component, the first thing that I need is the where to find it. So where to find it is the root component itself. It means the top level assembly. So I'm going to find it in assembly. And how I find it? Because I do have a name. So I know the name of component and I know where to find it. So I can write some code that will find that object in the assembly and will get that object as a variable value. So NXOpen. So first I will provide the component. Assembly is not component. And I will also provide the name. So type is given. So this is how we define any variable. The same thing I am doing here in the bracket. So component is defined. Then I do have a name. So string as well. So string is actually search name. So I will name it as search name. Then bracket complete. Then curly braces for this function. So this is the different function. Okay. So this is the different function. Now uh, imagine a assembly. Uh, the assembly has few components there, and there could be other components with other names. So what I can do is, one approach is, I can go and if you remember get length example, in that what we have done, there are several sketch entities, lines, arcs, etc. And what we are doing is, we are using a loop to go through all the sketch entities and find its length. So we do have get length API that we are using, and that API we are using on all the sketch entities one by one. Here we are going to do the similar thing. The only difference is, here we are going to uh, get through all the components one by one, and we'll check the name of the component. If the name of that component matches with what we want uh, to search for, then we will get that component name and continue our code further to get the position. So when we want to go through all of the objects starting from from start to the end, then that times it is more viable to use for each loop. So at least I have introduced you to the loop. At least the definition of loop I may have covered. So loop is something uh, where we define start point and we also define the end point. It means that start point and end point defines means how much times it is going to repeat. So that particular code block, how much time it is going to repeat, that is very well defined, and then it keeps on repeating for that many iterations. So let's say there are 10 uh, fruits in a basket, and we want to check all those fruits for certain thing one by one. So we will go and check each of fruit one by one. So one fruit one time, it means 10 times we are going to check that. So those 10 10 times we are going to check, it means there are 10 iterations going to be, and in each iteration, each object, each fruit will be checked. So one fruit one time will be checked, and like that 10 iterations for 10 fruits. So this is called iteration. So the same code is going to repeat for that iteration, and for each loop actually ensures that there is a defined starting point and end point. So let's start uh, for each. Okay, so this is the for each statement, which is the C# functionality that we are going to use. And after we mention for each, we can define what we want to iterate. So there could be several objects in a active document, whether it is part, assembly, whatever, and we wanted to go through all of them. So for each means it could be anything in number, but we are going to perform that action. That code block is going to execute repeatedly for each of the item, for each of the object. So this is what is meaning of for each. So each one will be picked up one by one. No one will be left out. No one will be checked twice. One item will be checked once. So this is the meaning of for each loop. So we don't need to take care of whether it could be 1,000 components there. For each means for each. it is going to go through each of them one by one, whether it is anything in number, but provided same same object type. So here we are going to deal with the components. Here we are going to check the component name. So I will mention component as an object inside for each loop. So component, and this is also where we have to define the name, because this is where we are defining variable. So component is being the object type. We have to define the identifier. So comp1 I will define. I'm Because there are a lot of such variables, similar variables you can see. Top assembly comp, and then comp1. So don't get confused. These are the different variables. Okay. So what I'm going to check is, I want to check component one by one inside an assembly. So inside an assembly means uh, comp comp is this variable I am using, comp, and then dot get children. This is the another API. Okay, and this returns the child components of the component means, so even if it is a child component, even if it is a assembly, we still call it component. That is the, like, maybe a little bit confusing for you, because you can see here in the root component, even being top assembly, because it is top level component, it means it is assembly. Though it is a assembly, but it is declared as component. And how we found it? We found it from component assembly, because the API itself is component assembly dot root API. So what we are doing now, we are actually from the top level, by accessing the top level component through this line, we are using get children. It means for that assembly, all the children components will be picked. So this is meaning of get children. So from the top component, we are picking all the children components. So uh, all the children components, it can be 2, it can be 10, it can be anything. So all those children components we are picking, and then we are going to check each component one by one. So this is what is happening. So in other words, if I say uh, comp1 meaning one of the fruit in that basket, and comp dot get children, it means it is that entire basket. So what to check? Each component to check. Where to check? Inside the basket. So this is what is meaning of this component from all the components available in a set. Now this for each loop is going to help me to go through all the components one by one. But uh, this will go through one by one. But once I found first of the component, then I have to perform some checking. I want to check whether the name is this. If this is the name, then I am good. I don't need to check all the thousands. If I found the name matching this name in the second iteration, then I can come out of that. I don't need to go further. I don't need to check all those 998 if I found in the second attempt. So how to check that? So for checking, if you remember, we do have comparison operators, double equal to, then less than, more equal to, like that. So all those are comparison related operators. So we can use that operator and compare the name of the component with this name. So it is that simple. So I have to do it using if. If means if the component name matches with the given name, then I'm I'm good with it. I don't want to continue further the looping part, and I can go ahead and pick up that object name because this is component. Okay, and this is the component name, sorry, variable name is comp1, and this the object type is component. And what and why I am doing this entire thing, because this name, which is string, is not just enough. I need the component object, and I don't know which component in the assembly has this name. So this is why we are writing all this thing. Actually, this is falls under uh, scanning the component or the entire assembly and comparing certain property, and if that property matches, then we continue further. So it is like that. And there will be a lot of scenarios. This is where you will need to use this kind of logic, whether it is sketches, whether it is features, it can be anything where you might need to use this one. Okay, so if I found a component with the name, so that condition I need to check. So what I will do is comp1, because this is the iteration that is happening inside for each loop. Comp1 dot name. So this is very obvious API. Dot name means I can get the name of the object. In this case, the object is component. What I will do is next, I will use some C sharp functionality, because you can notice this is entire uppercase. But what if by chance I get the name in lowercase? Then comparison won't match two names even if the letters are equal, if it is exactly same, but because of lowercase uppercase, my condition will be false. So what I can do is this name, whatever name of this component is, I can use to upper. To upper means we convert that name into uppercase. That's it. So to upper is the C sharp function. Double equal to is for comparison. We use single equal to in case of formulas or assigning a value. But here what we are doing, we are comparing two values. So for that, double equal to is the operator to use. Then space, then we do have this search name. Search name dot to upper. I will do to upper for search name as well. Bracket complete. So and then curly braces for the if condition. So what one thing you can notice, for each function we do have written our condition inside bracket. For if condition also we have written our condition inside bracket. And then if these two names matches, then simply what we will do is we will return the object. The object name is comp1. That's it. So if this name matches, then we will return the object, and then we can use this object further to find out the position. If not, then that condition will continue till the end. Okay. Then if not found, what will happen is, this is for each loop. If every component iteration is done, and then still we don't found that required stuff, then what is that? It means that the given name is not found, and in that case also we shall return something, we shall return null. because returning null is important in this case. Okay, I have missed one line here. Comp1 in one word actually. So this is how for each loop is written. I want to check each component inside the basket. The basket is component dot get children. Okay, so I do have written this entire function. Now it's time to come back to the code here and call this function, because we need to also define where we want to call that function. Call means where this function will trigger, where this function will execute. Being this public static void main, we our code knows that this is where I have to start. This is where, this is the line one where from where I have to start execution. But for all other functions that we write inside code, we have to define the entry point for that. This is by default going to be entry point because this is main function. But for any other functions, we have to define the entry point. Entry point means we have to call that function. So we can call that function here. And how we call it uh, is this, like this. Just after this input, because we need this input for this function, because this is the input. Against this name, the function is going to check, uh, the component name. So just after this line, I will write a line to call the function. Component uh, component to check name. This is the identifier I will use, and then is equals to, I can use this name, which is the function name, and as what we have defined inside here, I have to define the same things, same variables. In fact, I have to provide the inputs. Similarly, how we use any API, we provide inputs, parameters, and then we get something out from that API, or some action being done by that API. So similarly for any function, so we have to define two things. First is definitely a root component, which is top level assembly, because getting children API, get children API will work only on the top level component, right? So that is this one. So this we will provide as input, and also I will provide this name, search name, as an input. Bracket complete. So this way I am providing these two inputs, and then my code, my uh, this function will get the inputs to work on. It will work on these inputs. It will check all the components one by one, and also it will check for each component the name, the given name, and if it is found, it will return that name. That's it. So once that name is written, then we can use get position API. Get position API is very simple to use, but that is not the that is, but we have to create all the prerequisites first to make that work. Okay, then after this, we do have defined the parameters required for get position, and I can go and use the get position API. Get position into bracket pt point 3d, and then mx, which is matrix 3 by 3, bracket complete, bracket close. Yeah, one thing I am missing out. Let me show you. You can see all of these parameters, both these parameters are out parameters. So those are not input parameters. They return point 3D and they return matrix 3 by 3. So these are not input parameters. So I have to write out just before the parameter like this. Okay. So I am done with this. Now, uh, guide dot info write line. I will use this to print the information. I will use this to print the point information. So what I can do is I can go and write the name of a component. The name of the component is this, bracket, then other line. So this is the information that I am going to display once I found the coordinates. Info IntelliSense only starts after we put dot or at the beginning of the line. So info write line into bracket pt, pt is point, uh, pt dot to string. It means I am converting that point into a string and then bracket complete. Okay, so this way we can display the point information of this component. So so I do have some code on top, that's why it was not working. Okay, so I can go and delete this. It was not working means we do have the errors there. Now I think errors are gone away. So first I will show you this by copying this into a journal, and we'll make sure that it works there in NX. And after we see it's working, we can even go and debug. Developer edit, paste this code here. Now I will hit a play button. You can notice these two lines of information is displayed. X, Y, Z coordinates are displayed for this component. Now one more thing I can add to this, the matrix information. I can copy this line and instead of pt I will just replace it with mx, and let's run this again. Now you can see I got the xy xyz along with the orientation in the from the matrix xx xy xz yx yy yz, and then zy zx zz. So all these 9 parameters that represent translation and orientation of the object in a 3D space. So we do got this all information. Now let's uh, let's recap this entire journal, and I will recap it 2 times because I want you to gain this very well. Uh, when we start off, we need these 2 lines because we are dealing with assembly. And in order to deal with assembly, we do need a variable for component assembly. And after that, we do need a component variable which can hold the top level component itself. And how it holds that top level component is using API called root component. So these are the two mandatory things on top of other code for assembly. Now, once we do have this code, we can go and work with the assembly objects. It can be any objects in assembly. We can go and work with those objects because we do have got the access to top level component, the assembly itself. Now, our use case here is we need to get the position of the specific component. That specific component means the name of that component we do have as our input. Then we do have this as an input. Now, we, uh, in order to use get position API, if you can see here, this get position API, it clearly says void component dot get position. It gets the position of a component. But how it gets the position of component? Via component object. So we need the component object first to use get position API. So in order to get the position, in order to get the component object, the way that we do have, which is I would say again easiest one, because uh, for each loop can do that work uh, perfectly for us without any miss. So we have used for each loop. For each loop, we'll go into that assembly. We'll go through each of the components. And as I am sure that I'm going to access the each of the component one by one, then I can add further check or validation to compare the names. If the names matches, then I do have the component object. And this is what same has been done here. And I do have that component object, and as I got that component object, I can use get position API. And we know that whatever parameters are required for the API to use, we need to go ahead and declare them before we use that API. So that's why point and matrix is declared here. And once I'm successfully using this API, then I'm sure that I'm going to get the required information out, the point itself and the translation and orientation of a component. So this is what is done here. Now the recap with the C sharp point of view or in context with the programming. Now I do have declared another function get component by name. Get component by name is the function, but this function is actually the kind of function that returns a value, because you can see here I do have mentioned the function. uh, I do have mentioned this function, and inside this function I do have mentioned the object, because I want this function to return that object itself. So that component this function is going to return. And how it is going to return? The common sense is that I do need the assembly and I do also need the name to search for. So those are going to be the inputs for hunting. So what we are going to hunt is this name, and how we are going to hunt it from the top assembly. So top assembly is given as an input to this function, and search name is also given as an input. And with these two parameters, we do have a for each loop which goes through the entire assembly and find out all the components one by one. And then we do have if condition to compare the names, and if the names matches, then definitely we can come out of this function with the component object. As this function is a kind of function that returns a value, it means it will return that object no matter uh, whether you have it or not. Means whether you have that component inside the assembly or not, it is going to return something. So in worst case, let's say I don't find that component, then I don't need to use this line return null. At least it will return empty value, but at least it has to return that. Let's say if I don't have this line, you can see I have got an error. So it says something related to returning a value. This is a function that should return a value, and with this comment, this line commented, I'm not going to be sure that whether it will return or not. So this cannot happen. So it shall return something always. So that's why I have written null as well. And then uh, this is how this function is taken care, and this is the role this function has to play. This is related to the condition checking, and this is related to iteration on all the components. Okay, so this is how it works. Now there is enough actually. I do have repeated few things as well here, but that is to help you understand more about this type of examples. So that's it. Uh, you are anyway going to get an assignment on this, which will help you know more. But I'm sure that you have got the clarity, enough clarity about the topics those are covered in this example. With this, that's all for today. We are going to meet tomorrow with the next set of examples within assembly.